This is lesson 7.1. So to start it, we're actually going to talk about the names of polygons based on how many sides they have. So we should already be familiar with the triangle, figure with 3 sides, and the quadrilateral, figure with 4. So a 5-sided figure is called a pentagon. A 6-sided figure is a hexagon. 7 sides is heptagon. That's not the only way you can say it, but it's the way I'm going to refer to it in this class. 8 is octagon. 9 is so fun to say, nonagon. 10, like a decade, is a decagon. 11. So 11 is like one and a 10-sided figure. So like one, like Spanish uno, it's un decagon. And then 12 is like dos and decagon or do decagon. And anything else, the names exist, um, but we don't care what they are. So we're just going to refer to the rest of them as whatever number it is, dash gone. So n is always going to represent the number of sides for us. Even if it was a pentagon, n would be 5. But for anything past 12, we're just going to call it a 13 gon, 14 gon, 15 gon, and so on. So a diagonal, we've talked about diagonals when we talked about our parallelograms, but a diagonal of a parallelogram is a segment that joins 2 non-consecutive vertices. So in this hexagon here, we have 3 different diagonals drawn from point B. When we draw all the diagonals from a specific point, we make a bunch of triangles, and that's going to help us figure out the number of degrees that should be inside one of these shapes. So let's say we have a triangle, can't draw any diagonals in a triangle. So it's a figure with 3 sides, 1 triangle's inside a triangle, that's 180 degrees. With a quadrilateral, a 4-sided figure, when I draw the diagonal from, say, one of my points, I end up with 2 triangles. And if each of those triangles is 180 degrees, that gives me a total of 360 degrees in a quadrilateral, which we have talked about. A pentagon, which is a 5-sided figure, if I drew all my diagonals from this point, I now have 3 triangles in the picture. And 3 times the 180 for each triangle would be 540 degrees. For a hexagon, our 6-sided figure, all the diagonals drawn, we end up with 4 triangles. If each of those triangles is 180 degrees, that's really 720 degrees inside a hexagon. And this is going to continue forever and ever. But I don't want to have to make this chart every time I want to find, say, the number of degrees inside a 90gon, because that's going to take me forever. So what the better way to do is to have a formula, and we can come up with the formula right now because we can see a pattern in this chart. There was always 2 less triangles than there were number of sides, right? If there were 6 sides, minus 2 is 4 triangles. There were 5 sides, minus 2, there were 3 triangles. So if we call n the number of sides, there are always n minus 2 triangles in our figure. So if I want to know the sum of the interior angles of the polygon, that's going to be the number of triangles, n minus 2, times 180 degrees for every triangle. And I just want to talk for a second about this word right here, convex. We are only going to be working with convex polygons. We can't work with concave polygons. This just refers to the fact that no part of the shape is caving in, right? So a hexagon, a pentagon could look something like this to be convex. It could look something like this to be concave, right? That's kind of like caving in there. That's concave. We're only working with convex, not with concave. But n minus 2 times 180, that's going to give us the sum of the interior angles. So if we want to find the sum of the interior angles of a convex undecagon, we know n is 11. So that's going to be 11 minus 2 times 180, or 9 times 180. So that is really 1,620 degrees. So here's a try problem for you. Pause if you'd like. Answers are posted online. In our next picture, we have a figure with a bunch of variables inside, and we have to find the value of x. To know what I should be setting this equal to, though, I need to use that formula. This is a 5-sided shape. So if I did 5 minus 2 times 180, that'd be 540. So I'm going to add all of these up and set it equal to 540. So 3x plus 14 plus 3x plus 14 plus 2x plus 2x plus 142 equals 540. So that's 3, 6, 8, 10x plus 14 plus 14 plus 142. That's 170. Take away our 170 and divide by 10. So here's another problem for you to try. Pause if you'd like. Answers are posted online. A polygon can be equilateral. Remember, that means all sides are congruent. And a polygon can also be equiangular. That means all angles are congruent. When we learned about triangles, they had to go hand in hand. If it was equilateral, it had to be equiangular. But then when we got to our quadrilaterals, we saw that that wasn't true because a rhombus is equilateral but not equiangular. A rectangle is equiangular but not equilateral. If it has both, then it's called regular. So a square is actually a regular quadrilateral, but there are regular versions of every polygon out there. So if it is both equilateral and equiangular, it is regular. For example 3, the poles for a tent form the vertices of a regular hexagon. So they already told me that it's equilateral and equiangular. When the poles are properly positioned, what is the measure of the angle formed at a corner of the tent? So if I wanted to know just one of these corners, what would that be? Well, it would make sense if it's equiangular, then all of them would be x. So that's really 6x equals, and I should know how much it adds up to. And this is a 6-sided shape, so that would have been 6 minus 2 times 180. But I don't want to have to do like a 6x equals every time. I'm not going to have the pictures drawn. So we do need a formula that's going to have x equals, or the angle equals, everything already plugged in for us. So that is what it's going to end up being, is the sum of the interior angles on top divided by the number of angles on the bottom. In this case, that would be 120 degrees. For all other problems, if you're finding the measure of each interior of a regular polygon, we're going to take the sum of the interior and divide it by the number of sides. So that's going to be n minus 2 times 180 divided by n. So here's try 3. Use that formula. You can pause. Answers are posted online. For example 4, they're telling me the measure of each interior angle of the regular polygon, and it wants to find the number of sides. So I'm going to take that formula, and I'm going to substitute in 157.5 for the angle. I don't have anything I could plug in for n because that's what I want to solve for. So let's work on solving this. I'm going to multiply both sides by n because I want to get rid of my denominator. So they'll cancel here. So that's going to be n minus 2 times 180 equals 157.5n. I'm going to distribute the 180 to everything in my parentheses. So that's going to be 180n minus 360 equals 157.5n. I'm going to minus 180 from both sides. Keep hitting the wrong buttons. So this is going to be negative 360 equals negative 22.5n. And my last step will be to divide my 360 by my negative 360 by my negative 22.5, and I get n is 16. As long as I get a whole number for n, I did good. All right. If you get a decimal for n, something went wrong because you cannot have a decimal number of sides. So here's one of these for you to try. Pause if you'd like. Answers are posted online. In these figures, we are seeing the exterior angles, right? Exterior angles are angles formed when you extend the side of a shape. If I added up 120, 100, and 140, that adds to 360 degrees. If I added 105, 110, 105, and 40, that also adds to 360 degrees. Even though this only had 3 angles and this had 4, the inside angles added to totally different things, but I still ended up with 360. If I had 65, 98, 36, 50, 111, that also equals 360 degrees. So it doesn't really matter how many sides the shape has, the exterior angles will always add to 360. So the polygon exterior angle sum is just 360. There's no formula for this one. So let's take our picture, find the value of x. These are all my exterior angles. So 2x plus x plus 67 plus 89 equals 360. So that's going to be 3x plus 156. Take 156 away, so we get 3x equals 204. And when we divide both sides by 3, x equaled 68. Just like we were able to find each interior angle of a regular polygon by dividing the sum of the interior by n, I could do the same thing for each exterior in a regular polygon, because I'm going to take the sum of the exterior and divide it by n. Formula is much simpler than the interior one. So let's find the measure of each exterior angle of a regular 18-gon. So that means n is 18. We do 360 divided by 18. So each one is 20 degrees. So you go ahead and try this one. Pause if you'd like. Answers are posted online. Here we have the measure of each exterior angle of a regular polygon is 40 degrees. How many sides does it have? So this is similar to what we had to do where we had to find the number of sides given each interior. So just like that, we're going to take the formula for each exterior and set it equal to the angle. So this is going to be 360 over n equals 40. So basically, 360 equals 40n. Divide by 40, n is 9. So this would be a nonagon. So the last one is here for you to try. The answers are posted online, but that is the end of section 7.1.